Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have this surface z equals x square minus y square, and we have to describe the traces of the surface in each of these planes, xy plane, x equals 3 plane, and xz plane. So traces means what happens when the surface intersects each of these plane. What kind of curve do we get? What kind of picture do we get? Now, let's start with the first part of this problem, and then we'll describe how to figure out the traces for each one. Okay, so what happens in xy plane? So if you look in the 3D picture, here is say x, this is our y, this is our z. Okay, xy plane means this plane in the bottom, right? So remember what happens on xy plane? Z is 0 on that plane, right? Okay, so all we have to do to figure out the trace is plug in z equals 0 in the equation and then solve and see what kind of curve we get. So plug in z equals 0, we get 0 is equal to x square minus y square. And therefore, bring the y square on the left hand side, so you get y square is equal to x square, and then solve y is equal to plus or minus x. Therefore, when this surface intersects this xy plane, you get these curves. And what are they? Y equals positive x and y equals negative x. They're lines. You know those lines, right? So we can project just the xy plane here and draw the trace right here. So this is my x, this is my y, and I'm going to draw the trace of the surface, and they are just the two lines. One is y equals x, and the other one is y equals negative x. So that's the trace of this surface on xy plane. Okay, moving on, the x equals 3, this plane. First of all, to figure out the trace, all we do, we already have x is equal to 3, so we just have to plug in x equals 3 in this original equation and then see what we have. So let's plug in x equals 3 in the equation. So z is equal to 3 square minus y square, and so z is equal to 9 minus y square. So that's our equation. Now what does that represent? Do you remember? This is just a parabola in 2 dimensions, right? In just z and y. So looking at the equation itself, you can tell that where are we going to graph it? Which plane? You see it's a z and y. Those are the variables. So that means we will be doing it, we'll be graphing it in the yz plane, right? That's telling you right here. But what does this x equals 3 plane really looks like? So x equals 3 is a plane passing through x equals 3. And what does that mean? That means that it will be a plane passing through x equals 3, if this is 3, and it will be parallel to the yz plane. And that's why our equation here has y and z variables, because the plane is parallel to yz plane. Okay, so I can try to give you a quick idea here. It is sometimes difficult to draw this. So it is the plane, as you can see, it will be passing through x equals 3 like I said. So it's a plane like here through x equals 3, but as you can see it's parallel to the yz plane. So we are projecting that x equals 3 plane right here. This is our yz axis you can consider, but this is when x is equal to 3. Okay, that plane, just projecting. All right, and we know that our trace is a parabola. What kind of parabola? You see the y square has a negative sign, which means it will be opening downward. So it's a parabola opening downward, and see y equals 0 will give you z is 9. So it will be something like this. Okay, passing through 9 here. So that's the trace on the second plane, x equals 3. Okay, finally, moving on. The last one, we have to find the trace on the xz plane. So xz plane is this plane, right? The x-axis and the z-axis plane. And what happens on xz plane? We know that y is 0. And the same thing again, you plug in y equals 0 in the equation. So you get z is equal to x square minus 0, which means z is equal to x square. And what does that represent? Again, that's a parabola. Okay, so, and again, you can see that the variables are z and x. So we are just projecting that plane here in the 2 dimension. So this is our x, this is our z, and this is a parabola that's opening up. You know what z equals x squared will look like. Just like that. Okay, so we got all our traces, and now finally we have to classify this surface. What kind of surface is it? First, notice the equation. It is in a standard form already. Notice that z has a degree 1, which tells you that this is a paraboloid first. This is a paraboloid. Further, notice that all these traces, this one we got 2 lines, and these ones we got 2 different parabola. And therefore, it's telling you this is a hyperbolic paraboloid. So the surface is a hyperbolic paraboloid. And that completes this problem. Thank you.